Hello everyone, this is a little bit of a webcast I've made for you to talk about our last experiment, which was, is force a vector? Now I'm going to show you some ways of handling the data you've got from that and showing you some ways that are perhaps smarter than others. What I'm going to start with is a Word document. So I've got a Word document ready, here we go, and you can see it's a plain Word document with nothing fancy in it. I'm going to zoom in just a little bit so I can see the page, and what I'm going to do is I'm going to insert an arrow. So I go into shapes and I insert an arrow. What I'm going to do is draw the similar shape maybe to what you might have. So you should have something that looks basically like a Y type shape. So I'm drawing an arrow downwards. This is going to be one arrow straight downwards. And I'm going to insert another shape, which is another arrow. I'm going to draw that slightly off to the side, maybe like this direction. I'm going to say maybe, that long. And I'm going to draw a third arrow like this, going maybe up but this way. Yeah, let's say like that. I think that'll work. Okay, so what do I do with these three arrows? Well, remember, the aim is to see if force is a vector. And the way we'll know that is when the forces are in equilibrium, that means that the sum of the forces are zero. So there's two possibilities. In equilibrium means that the central weight is at rest. It is not moving, as well as the two side weights are at rest. They are also not moving. So what we want to do to ensure that, to take that situation is, at that point in time, the sum of forces must be zero because the weights aren't moving. The sum of forces are zero because the weights aren't moving. Now, if it's a vector, force is a vector, then we'll need to do vector addition. If force is not a vector, then we'll need to not do vector addition. So I've got a situation here, so I'm going to say that this vector here is 5 units long. So I'm going to insert, and I'm going to put a shape, a text box with that. I'm going to say this one here is 5 units long. Now, I've just made that up, but you will actually have correct data for that. Oh, it just vanished, so I'll make it a little bit longer so you can see it. There it is. This one's 5 units long, and copy this one and paste it over here. This one's going to be, I don't know, why don't we say 4 units long, and this one over here, I'm going to say this one is going to be, what do you think? Looks slightly longer, different direction, but let's say 4 units as well. Let's let that be like that. That's fine. So if this is correct, and we know this is what we got, this means that it was at rest. So we have 4 units up-ish plus 4 units up-ish makes 8 units up, and 5 units down makes 3 units overall. That would mean that there was force left over, that the sum of the forces, so if I tell you what I'm saying here, remember this, I'm going to insert a symbol here. I need to go and get more symbols. I need to go and get my Greek sigma. Where's that going to hide? Looking for Greek letters. Getting closer. Oops, too far, I think. Yeah, I've gone somewhere too far. So I'll use an equation instead. Come on, computer's being slow. So I'm going to take a script, large operator, there it is there, that the sigma, the sum of forces, must equal 0. There we go. So in this case, if we were to add them as scalars, we would have 8 units up, take away 3 units down, take away 5 units down, makes 3 units. That's not 0. So we have to presume, therefore, it's not a scalar. So, the next thing we need to do is check if it's vectors. So what I need to do first of all is make sure these arrows I've drawn are actually the same length as I want them to be. So I've said this is 5 units long, and I'm going to go into this. I click onto it once, and I right-click it. And my computer responds. I said right-click it. Drawing tools there. I can change the rotation of it. have more rotation options, and here we go, I can specify the actual size. So I said it's going to be 5 units long, so I'm going to say the height is 5 units long, right? And there is no width, it is 0 degrees, and my height, my rotation, is going to be 90 degrees. Now that's because you can see it's rotated there at 90 degrees. Yeah, it's turned off wrong. So I need to go back into this, and I go into more layout lines, and I go back to size, and I'm going to set the rotation to be 0 degrees this time. Ah, there it is. It's now pointing straight down. So I said this one here has to be 4 degrees. So I can go into the 4 units long, so I'm going to go to more layout options here. And I'm going to change this size here to make the absolute width this time 4 centimeters, because I said it's going to be 4 long. And the rotation then to be, well, if I look at that arrow again there and I say this is 0 down there, yeah? So let's put that in like this now. You can see it's the 0 is there now. So I put that back where it wanted to be. Go back into the layout again as I did. And go back to size, and I want that layout to be, oh, let's say negative 30 degrees. Okay, and you can see it's now pointing upwards slightly. Put it back where I wanted it to. So that's now going up at 30 degrees. Yeah? So now I go to this one, I do the same thing. I'm going to say that's 4 units long, so I go to more layout options. I go to size. I go to make this here exactly 0, and this one is going to have to be 4 as well, yeah? So say 4, there it is there. That's 0 again. So I want to make that go upwards again. So I'm making it go this time clockwise. You can see I want to make it rotate clockwise. I want to make it go up this way, right? So I go to more layout options, and that time now I'm going to go to my size. It's at 0 degrees, so I'm going to try putting this one at, say, 60 degrees. See if that worked. Yep, there it goes. Now facing the right way. So those are my 2 arrows, yeah? There's the one going down, which is 5 units long at 0, and this one's at 30, and that one's at 4. So now I can do what we talked about doing in terms of moving the arrows. Now when we're adding vectors, we have to move the arrows so that the tail, the back end, the tail of one vector is on the head of the other vector. So just place that there like that. Job done. Now take this one here and place it there. Now because of the data I actually chose, well, mine doesn't work very well. I'm hoping that yours works a lot better than that. Well, it should do, considering you actually did it with real things rather than completely made up data. But what do I do with this? Well, you remember I need to find the resultant. The resultant vector is a vector that goes from where you started, here, to where you ended, there. That's my resultant right there. So when I release that, I've got my answer. The only thing I need to know is how long is it? Well, fortunately, you can see, if you remember, going back into layout and into the size, I can see the absolute height and the absolute width. Yeah, 0.56 and 1.89. Yeah. So that means I can do a simple bit of Pythagoras in order to find that. So I'm just going to go to Google. Oh, this screencast-o-matic where I started, so I go to Google. I'm just going to use the Google calculator, because why not? So I'm going to say the square root of, it was 0.56, I think, squared, plus, was it 1.89? I think it was. It doesn't matter. You can type in whatever numbers you want. Squared equals, comes out to 1.97. So the actual length of that arrow is 1.97. Yay. Job done. So I go back to here, and I know this arrow here, this one right here, which I'm going to make pretty in red, why not? That's pretty red colour, there we go, that one, is now 1.91 long. So I know that. Now remember that I need to find the length of this one, and this one, and this one as well. But I knew that because this one was 4 units, plus 5 units, plus another 4 units, makes a total of 13 units. So my percentage error is going to be the length of this one divided by 13. So I can take this number here, 1.971, so take that, to copy that. Whoops, trying to copy that. There we go, copy that. And paste that into here, divided by 13. Yay, so it looks like my error is about 15%. 0.15, 15%. So I have 15% error. That's pretty ugly. I hope yours is a lot better than that. There's another way you can do the same thing using Excel and some equations. If you prefer to do it that way, come talk to me and I'll show you. But obviously the basics is, well, get your Excel program open. Oh, I may as well do it since I've got you here. You can stop now if you don't want to do it with Excel. Of course, learning how to use Excel might be important for your EPI. Well, here we go. Finding the resultant vector worksheet. Why would you want to do it this way? Well, once you do it once, you can do it as many times as you want. So what we're going to have here is vector number, vector length, and vector angle. Yay. So I'm going to make those pictures a little bit bigger so we can see them. There they are. Woohoo. And now, of course, we need to find the various components of the vector. You might remember the process called resolution of vectors, which is based off the idea of using right-angled triangles. So I need to find the horizontal component and the vertical component. Yeah? So I have vector number 1, vector number 2, and vector number 3. My vector length for number 1, which is a downward vector, was 5. And we're going to say that on a clock, if you like, that is 0 degrees is going straight across from the center to 3 on the clock is 0 degrees. So this is at negative 90 degrees. Yeah. And then this length was 4, and it was at going slightly up, as you recall. So that will be at 30 degrees. And this was 5. So this length was also 4, and that was going from 3. If you think about it, going all the way across from 3, that was 90 degrees up to the top. That's at 12. And then another 30 degrees across till you get to 60 degrees, which is 120 degrees. Right. Okay. So now I just simply need to use this program in here in order to create that calculation. So I need to do the horizontal of any one of these is the flat section. So if you think of that of the vector as the hypotenuse and the angle at the center, that means the flat section is going to be adjacent to the hypotenuse, which means we're going to be using the cosine. So I have to go cosine, yeah, returns the cosine of an angle, but I need the angle now, and I need to do this in terms of radians to degrees, because cosine in this works in radians. So I think it's the radian, converts degrees to radians. There it is. Radians of negative 90. Did this work? Let's see. Yeah, it's come to something to negative 17. Wow, are you surprised? It's 0, basically. So I'm going to do the same thing, copy this one down and see if that one works as well. 0.86 is looking good. And negative 0.5. Hey, they all work nicely. Beautiful. But that's merely the angle, yeah? So, well, I'm going to clean it up a little bit because I'd like to round it. I'm going to round that to only, 3 digits. There we go. That makes 0. Hey, whoops, daisy. Oops, I rounded it to 0 digits. I meant to round that to 3 digits. That's better. Let's try that again. Rounding. There we go. Nice numbers. Yeah? And obviously, the vertical is going to be the same, isn't it? This is only the angle, though, yeah? So we need to multiply that by the length of the hypotenuse. So we're going to multiply that, hit the asterisk key, by the vector length. There we go. And let's follow that down. There we go. All jobs done. Nicely done. Over here, it's going to be the sine, the same way. Sine of the radians of this. Close it off. Hey, look, negative 1. Again, I hope not surprising for reasons that you should know from your math methods by now. But again, let's round that off a little bit.